In the last section, we talked about rationalizing a denominator with one term. Now in this section and the final section for today, we will be talking about rationalizing a denominator with two terms. And as you can see from the topic, it says using conjugates, so you can probably guess we're going to be using conjugates to rationalize it. So before we do this, let's talk about the difference of squares property. And I want to point out, so I told you guys the perfect square trinomial, the difference of squares, these are really important formulas, and they're obviously not getting away from us. So for the difference of squares, what does it say? A plus b, a minus b. So if you multiply two conjugates together, you will get a squared minus b squared, not plus. Right? Don't do what I did a few days ago. So why are we going to be using this property? So let's take a step away from this example and let me talk about a different example for a second. So let me use a different color. If I was given maybe, I don't know, like 1 and then square root of x plus 1, right? So when we do one term, I told you guys to just multiply whatever is in the denominator, right? Why don't I do, and then actually let me fix that. So even if you had like 2 square root of 5, you just want to multiply it by the by whatever is under the radical, right? So you wouldn't, oops, 1 second. So in this case down here, you would just multiply it by 5 over 5, the square root of 5, right? If you do 2 square root of 5 over 2 square root of 5, that's also fine, but you'll just have to, there'll be more to simplify. So to reiterate, when you just have one term, because this is essentially, it's kind of like one term, you just multiply it. You just multiply whatever is under the radical, right? So let's go back to the top. And so the top, I want to rationalize this. So why don't I just multiply this by the square root of x plus 1 over square root of x plus 1? Let me show you. So if I do that on the top, it's just x plus 1, right? When I do this, so x plus 1 times x plus 1, that is a perfect square trinomial. So if I multiply these, this becomes x plus 2 square root of x plus 1, right? So yeah, we got rid of the square root under the x, like for the first term, and then there's no square root here. But as you can see, right here, right in the middle, there is still a square root right there. And that is a big no-no, because what does the second condition say? What does the third condition say? It says no radicals in the denominator. All we did when we multiply it by the same, like whatever is on the bottom, we just made our situation worse, right? So that is why we don't do that. That's big no. So what if, let me use maybe blue. So now what if I do multiply it by the conjugate? Then I'll have 1 over square root of x plus 1. And then if I multiply it by the conjugate, what's the conjugate of this? It is the square root of x minus 1. Right? What is that? So this would be square root of x minus 1. And over here, this would be, so square root of x times square root of x, that's x. And then square root of x times negative 1 is negative x. And then 1 times square root of x is square root of x. Those cancel because this is a difference of squares. So this is just a squared and then minus b squared, so it's 1. So a was the square root of x and b was 1. And as you can see, this in the denominator, there are no more radicals whatsoever. Right? So this is why we multiply. This is why when we rationalize the denominator with two terms, we always use the conjugate. So now, let me erase all of this. So now let's start with our example. So looking at our example, maybe I'll use purple. Looking at our example, we want to rationalize. I noticed that the 3 and the 6, they both have a 3 in common. So what am I going to do? I'm first going to factor that out. So then this becomes the square root of 5 plus 2. If I distribute it back in, we will get the original denominator. So now, what am I going to do? I don't have to multiply it by 3. So like when I said with the 2 square root of 5, you just have to multiply them by square root of 5 over square root of 5. Same thing over here. I'm just looking at this term. So, or this factor. So I'm going to multiply it by square root of 5 minus 2 over square root of 5 minus 2. Right? And when I do that, so I'm just going to write it out fully so you guys can clearly see what I'm doing. So give me 1 second here. Right, so I just did, so since I multiplied, I did numerator times numerator, denominator times denominator. So now, over here, same thing, like when you have like 3x plus 5, or yeah, x plus 5, we just distribute this 3. So same thing with this, we're still going to distribute, so this becomes negative 2 square root of 5. Actually, I'm sorry. Let's take a step back. Before I distribute anything over here, how about we just focus on the bottom first? Right, so this is a 3. And then so the square root of 5 plus 2, square root of 5 minus 2, these are conjugates. Right? If you don't have conjugates in your denominator, ignoring the 3, like over here, if there's no conjugates, then something went wrong, and we got to go back and fix it. But square root of 5 plus 2, square root of 5 minus 2, they are conjugates, so then I can use the formula. So this is equal to 5 minus 4, right? Because it is square root of 5 squared minus 2 squared, right? So this becomes minus 2 square root of 5 minus 2 over, and then 5 minus 4 is 1. 1 times 3 is 3. Right? If you want, so like I tried doing it maybe earlier, if you want, you can distribute this negative 2. It's not necessary, but I'll go ahead and do it anyway. So when I distribute that, this becomes negative 2 square root of 5. Negative 2 times negative 2 is positive 4. Right? Any of these solutions, this one or this one, I would accept. Right? And these are our topics for the day. If you guys have any questions, feel free to ask. Or if you see any mistakes, please let me know. Right? You guys have a nice day.